Our team is the high altitude rocket team, and our goal is to launch a rocket, an entirely student designed, built and manufactured rocket to a minimum altitude of 100,000 feet.
So the project as a whole is the showcase launch for the Spaceport America Cup. And OSU was specially chosen to do this showcase launch because the rocket teams have done very well in the past. So the electricals part was designing all of the electrical systems for the rocket. And the electrical systems involved are the avionics bays, which sit inside sections of the rockets. They have a PCB on them and all the electrical components that collect data. And then the second part is the ground station. And the ground station receives data from the avionics boards over this antenna and then displays it on a web page that anyone can access.
We had to build 2 solid rocket motors that could give us the capability of reaching 100,000 feet. It's actually never been done before on student motors of this size. So we built these 2 motors. So this bigger one will be ignited on the ground, and it puts out about 500 pounds of thrust, and it'll get it to an initial altitude, at which point we can ignite the sustainer, which will take us to 100,000 feet.
I'm the team lead of the avionics sub-team, and we're essentially the brains of the rocket. We're trying to go for a minimum diameter rocket. Usual rockets will have a centering ring, so you have a wall spacer, but we want to have the wall as close to all of our internals as possible so that it can minimize drag. You can maximize altitude. So that's what we're trying to do, and that's what really drove our design for all of our sub-teams.
The problem here that we're trying to solve is that we're launching a rocket, and we want to be able to retrieve it. So we don't have internet out there. We also don't have mobile service, and GPS cuts out at a certain speed. And so once it's coming down, we'll be getting that longitude and latitude, and from that, essentially a team will be able to locate where it is.
So the biggest problem we ran into was that it's really hard to find materials that can withstand these kind of conditions. So we had to find those materials that would be able to withstand that kind of temperature for the time we needed. That was definitely a good experience. You learn a lot about how people interact with each other by working in a big interdisciplinary team like this. So.
We put a lot of effort and our lives and souls into this to make it work.
And the fact that we're going to be able to retrieve a rocket, like, how often do you get to say that you're able to do that? So I think that's pretty awesome.
And just launching big rockets is really fun.
Yeah, we're going to do it. It's going to go up, it's not going to explode, it's not going to crash, we're going to get it back, and we're going to put it over the mantle. Be like, this is our accomplishment.